Well, in this video, we will do 5 examples of solving a second-order differential equation with complex roots. We will go over the principle of superposition, 2 forms of the general form, and go over transient terms and solutions. So in the previous videos, we have learned how to solve when we are given real roots. What happens if we are given complex roots? So you are given ay prime plus by prime plus cy equals 0. You know that's homogeneous. Find the so step 1, you would find the characteristic equation, the auxiliary equation, where you figure out your a, b, and c, solve, or use quadratic formula. Step 3, find the general form, right? This is all familiar. You get y equals c1e raised to rt plus c2e r subscript 2t. If you're given an initial condition, you would find the c1 and the c2. So what happens if your roots are complex? You would have to use this formula. It's very almost similar to this. The only difference is now you have a cosine b beta t, and then this is alpha of t. So it's c1e raised to the alpha t times cosine beta t plus c2e raised to the alpha t times sine of beta bt, where r is alpha plus or minus bi. Okay, so step 4, find C1 and C2 if you're given an initial value problem or initial condition. Okay, let's talk about principle of superposition. So you have y equals C1 y1 plus C2 y2 of yt equals e raised to the rt. So this method is used to solve any second order linear equation of the form y prime plus pt y prime equals g of t, regardless whether its coefficients are constant or non-constant or homogeneous or non-homogeneous. Okay, so let's look an example. Maybe this will all make sense. So find the general solution to the differential equation of y prime minus 4y prime plus 13y equals 0. So step 1, you would find the characteristic equation. So set it up as ar squared plus br plus c equals 0, right? Let's see, let's figure out our a, b, and c. So our a looks like it's going to be 1. My b is going to be like -4. And my c is going to be 13, right? And then just put it in r. So it's going to be r squared minus 4r plus 13 equals 0. And then I'm going to solve. Can we factor this? Two numbers multiply 13 when added gives you -4. No, right? You cannot factor. Impossible. But that doesn't mean it's imaginary, right? So let's just use the quadratic. So what's our a, b, and c? Our a is 1, my b is -4, and my c is 13. So it's going to be r equals opposite of b, which is +4, plus or minus root b squared minus 4ac. So I know I could do, but the b squared, that's 16. Minus 4 times ac, I don't really know. My a is 1, my c is 13. all over 2 times 1. So I get r equals 4 plus or minus, when you put all this in the calculator, 16 minus 4 times 1 times 13, that is square root of negative 36. All over 2. So you get r equals 4 plus or minus. Remember, you cannot have a negative in the radical, so what you do is take out an I, and then this is all over 2. So you get r equals 4 plus or minus, square root of 36 is perfect, it's 6, and then you have this I all over 2. And if you divide each term by 2, so if you divide the 4 and the 6i by 2, you get 2 plus or minus 3i. Okay. Step 3, put it in the general, we have a complex root, so we're going to use the complex general form. C1, E. So if r equals 2 plus or minus 3i, our final answer is, so this 2 represents your alpha, this 3i represents your beta. Okay, so it's going to be y equals c1. We don't have a c1 because we don't have an initial condition. E raised to the alpha t. Our alpha is 2 t, and then you have cosine of 3t plus c2 e raised to the alpha t. So my alpha is 2 sine, and then my beta is 3. Okay, so that is your final answer. Okay, let's move on to example 2. Okay, example 2 says find the general solution of the differential equation, and I did not give you the problem. I'm going to give it to you right now. So it is 4y double prime of 2y prime plus 37y equals to 0. Okay, step 1, put it in the characteristic equation. Okay, figure out your a, b, and c. So your a is going to be 4. Your b is, this should be 24, not a 2. It's actually 24y prime, so my b is going to be 24. And my c is, oh my gosh, I wrote it completely wrong. My c should be 37. Let me erase this. So this should be plus 24y prime, and then this should be erased. This would be plus 37y. So my c is going to be 37. Okay. So so we're going to solve. So it's going to be 4r squared plus 24r plus 37 equals to 0. Can we factor this? Not nicely. I mean, we could try bottoms up, but I'm not even going to try it. I'm just going to just use the quadratic formula, right? So if I'm going to use my quadratic formula, my A is going to be 4, my B is going to be 24, and my C is going to be 37. So R is going to be opposite of B, which is negative 24, plus or minus root B squared, which is 24 squared, minus 4 times AC. So that's A is 4. I mean, your A is my A is 4, and my C is 37, all over 2A. And I get negative 24 plus or minus 24 squared is positive 576. 4 times negative 4 times 4 times 37 is negative 592, all over 8. So I get R equals to negative 24 plus or minus square root of negative 16, all over 8. You can't have a negative in the radical, so you take out an I. So you get negative 24 divided by 8 is negative 3, plus or minus square root of 16 is 4, so it's going to be 4I. Actually, let's just, before I divide everything by 8, let's just simplify it. So it's negative 24 plus or minus square root of 16 is 4, so that's 4I all over 8. And then when you divide it by 8, you get negative 3 plus or minus 1/2 I. Okay, so this negative 3 is it's a complex root, so this negative 3 is your alpha. This 1/2 is your beta. Yeah, so this is definitely complex. Step 3, put it in the general complex form because we have complex roots. So you got to put it in this form. Okay, so if R equals negative 3 plus or minus 1/2 I, my alpha is negative 3, and my beta is 1/2. So your final answer is going to be y equals C1 e raised to the alpha, which is negative 3t, cosine of 1/2 t plus C2 e to the negative 3t, sine of 1/2 t. So that's your final answer. Okay, let's talk about transient terms and solutions. So transient terms and solutions. We say that CE raised to the negative x is transient, negligible, since e to the negative x goes to 0 as x goes to infinity. So it's true, right? As e go to, if you replace negative x with infinity, that's e to the negative infinity, which is 0. And any remaining terms are called the steady state terms. For example, we have yt of y subscript 1 minus 2 times e raised to the negative t is sine t plus 2 sine t. So e to the negative t, e to the negative t sine t is transient. And then the 2 sine t is your steady state. Okay, so you could think of it, you could think of this as thinking of driving an old car. And if you hit a pothole, you may bounce up and down for a little bit, then it goes back to normal. So that's the same thing as the transient terms. So this y1 can change, right? So if y1 changes, it would look, so you see the different colors? It would look, it could be that or this. But eventually it's gonna even out. It's gonna eventually curve like this. And you have a transient term when the limit as x approaches positive infinity of e to the negative infinity. When you replace x with infinity, you get 1 over e to infinity, which is so much as it, which gets very close to 0. Okay, let's talk about general solutions from previous examples. So we have, you've seen this one before. This is real roots. Y equals c1e to the 2t cosine 3t plus c2 e raised to the 2t sine of 3t. Uh, so as you can see, like on this one, you have y equals c1 e raised to the negative 3t cosine of 1 half t plus c2 e to the negative 3t times sine of 1 half t. You have two transient terms, meaning it goes to 0, meaning you have two transient terms. Your two transient terms are e to the negative 3t and e raised to the negative 3t, right? Meaning it goes to 0, meaning it goes to 0, meaning you have a transient solution. So if it goes to 0, that means you have a transient solution. So that's what it means when you have transient terms and solutions. Okay, let's do example 3. Solve the initial value problem of y double prime of 4y equals 0 when given an initial condition of y of 0 equals 5 and y prime of 0 equals 6. So, yeah. So first step is I would set it to 0 or figure out my a and b and c. So be careful. We don't have a y prime. Um, so we're going to replace that with 0. So my a is 1, my b is 0, and my c is 4. So we have r squared plus 4 equals 0. That would be, yeah, r squared plus 4 equals 0. And then step 2, I'm going to solve. So I'm going to subtract 4. I get r squared equals to negative 4. Take the square root. I get r equals plus or minus 2i. So we don't have, it's going to be r equals 0 plus or minus 2i. We don't have a real, so our real is 0. So that's your alpha. And then your beta is 2. Step 3. We're going to put in the general form. So it's going to be y equals c1 e raised to the alpha t times cosine of beta t plus c2 e to the alpha t sine of beta t. And let's see, our alpha is 0 and our b is 2. So let's put that in. Okay, e raised to 0 is just 1. Anything raised to 0 is 1. So this is going to be y equals c1. This e raised to 0 is 1, so that's going to be cosine of 2t plus e raised to 0 is 1, so that's c2 sine of 2t. Since we don't have e to the negative t in our answer, this is considered a steady state term and which will never be approaching to 0, right? Let me write this out. We don't. Okay, step 4. So what we have to do next is find y prime. So what was our, because we remember, wait, okay, so I think we need to plug in our initial condition. So what do we have? We have y equals c1 cosine of 2t plus c2 sine of 2t, right? Let's find y prime because remember we were given a first derivative initial condition. So let's find y prime. So y prime is, what is the derivative of c1 cosine of 2t? Well, c1 is a constant, so you just use the chain rule. What's the derivative of cosine? Negative sine. And then you take the derivative of 2t. So that gives you negative 2c1 sine of 2t plus, what is the derivative of sine of 2t? It's going to be 2c2 cosine of 2t. And then you plug in an initial condition. Y of 0 equals to 5. And we also know that the y prime of 0 equals to 6, right? So we're doing this just to find our C1 and our C2, right? Okay, let's do that. Let's find our C1 and our C2. So y 0 equals 1. This 0 represents a t. This 5 represents your y. And then this 0 is like your t. And and then this 6 is like your y. So we have y and y prime. Let's look at the first one right here. We said our y is 5, so it's going to be 5 equals c1 cosine of 2 times 0 plus c2 sine of 2 times 0. So that's 5 equals c1, and then cosine of 2, 0. Cosine of 0 is 1, right? 2 times 0 is 0, and then cosine of 0 is 1, and then 1 times c1 is c1. And then sine of 0, because 2 times 0 is 0. Sine of 0 is 0, so that just disappears. So you have 5 equals c1. Let me box it. And then we're going to plug in this other condition in the y prime. So my y prime is 6. So it's going to be 6 equals negative 2. And my c1 is 5. And then it's going to be sine of 2 times 0 plus 2 c2 of cosine of 2 times 0. And that gives you 6 equals 2 c2. Sine of 0 is 0. Cosine of 0 is 1 times it by 2. That's how I got 2 c2. Solve for c2, so I'm going to divide this by 2. And I get c2 equals to 3. Okay, so my y, my final solution is going to be y equals 5, because my 5 is my c1, cosine of 2t plus 3 sin 2t. Okay, so that's my final answer. Okay, let's move on to example 4. Okay, example 4 says solve the initial value problem y double prime minus 8y prime plus 17y equals 0, where y of 0 equals negative 4 and y prime of 0 equals to negative 1. So first step, put it in the characteristic equation. So what I mean is put it in this AR square plus BR plus C equals 0. My A is 1, my B is negative 8, and my C is 17. So it's going to be R squared minus 8R plus 17 equals to 0. Can we factor this nicely? Two numbers multiply 17 and when added gives you negative 8? I don't think so, right? You only have two choice, 1 and 17, that's it. Or 17 and negative 1, or negative 1 and negative 17. It'll never add up to negative 8. So what you're going to do is solve by using quadratic formula. So it's going to be R equals negative 8. Wait, what would be our A and our B? Our A is going to be 1. My B is going to be negative 8. And my C is going to be 17, right? So it's going to be negative. The opposite of B is actually positive 8 plus or minus root B squared, which is 64, minus 4 times 1 times C all over 2. So it says R equals 8 plus or minus 64 minus 4 times 1 times 17, that's negative 4. All over 2. And I get 8 divided by 2 is 4. Plus or minus Actually, before I divide everything by 2, let's kind of clean this up. It's 8 plus or minus. You can't have a negative in the radical, so you take out an I. And then this is 8 plus or minus. Square root of 4 is 2, so that's 2I over 2. So that is going to be 8 divided by 2 is 4 plus or minus I. Okay, so your 4 is your alpha. Your I, or this one I, is your beta. Step 3, put it in your general form. So it's going to be y equals C1 e alpha t times cosine of beta t plus C2 e alpha t times sine beta t. Okay, so it's going to be, let's see, our alpha was 4 and our beta was 1. So it's going to be y equals C1 e, our alpha is 4, so it's 4t cosine of 1t plus C2 e to the 4t sine of 1t. So this is your general solution. But I think we were given an initial condition, right? Yes, we were given initial conditions. So we're going to have to somehow find our C1 and our C2. Also note that we don't have any transient terms since they will never go to 0. So we'll never go to 0. So step 4, you're going to plug in initial condition. Okay, so it's going to be C1 e, and our alpha was 4, so it's going to be 4t cosine of t plus C2 e to the 4t of sine of t. Uh, maybe we should find, before we plug in this initial condition, uh, right, this is your t, this is your y. What should we do? Should we find, I think we should find y prime. So let's find y prime. So how do you take the derivative of this? We have C1 times e raised to the 4t times cosine t. Now, e to the 4t is not a constant, right? So you have to apply the product rule, right? For these two terms. C1 is a constant, so you can just factor that out. And then once you take the product rule, the product rule of e to the 14 cosine t, just bring down the C1. So it's going to be C1 e to the 4t times the derivative cosine t, which is negative sine t, plus cosine of t, and then take the derivative e to the 4t, which is 4, bring down the c2, e to the 4t. So when you kind of clean that up, you're going to get y prime equals negative c1 e to the 4t, the sine of t, plus 4 c1 e to the 4t, cosine of t, plus c2 e to the 4t, cosine of t, plus 4 c2 e to the 4t times sine of t. And then I think we should plug in our initial condition, y prime of 0 equals 1. And actually, now let's plug in our initial condition. So let's start with, so we have our y. Let me box that. And our y prime. Ooh, this is a, yeah, 1. So let's do that. So that would be, so let's plug in our initial condition of y of 0 equals to 4. And that will give you this should be, I made a mistake right here. This should be negative 4. I don't know why I put positive 4. So yeah, let's do that. So that would be negative 4 equals c1 e 4 raised to the 0, 4 times 0, right? Cosine of 0 plus c2 e 4 to the 0 sine of 0. And that gives you negative 4 equals c1 e 4 to the 0 is 0, so that's e to the 0, cosine of 0 plus c2 e 4 times 0 is 0, sine of 0. So that's going to be negative 4. c1 e raised to the 0 is 1. Cosine of 0 is, what is cosine of 0? 1. Plus sine of 0, sine of 0 is 0, anything times 0 is 0. So you get 1 times 1 is 1, so that's going to be c1 equals negative 4. And that's one of your answer. That's one of your c1. Now let's find our c2 by plugging it into our y prime. So our initial condition for y prime is y prime of 0 equals negative 1. So we're going to put that condition into, what is it, our y prime right here. So that's going to give you negative 1 equals to negative c1 e to the 4 times 0 sine of 0 plus 4 c1 e to the 4 times 0 cosine of 0 plus c2 e 4 times 0 cosine of 0 plus 4 c2 e 4 times 0 sine of 0. So that's going to be negative 1 equals to 4 c1 plus c2. So that's going to be -4 equals to 4, and then C1 is -4 plus C2. That's going to be 4 times -4 is -16 plus C2. Add 16. So I get C2 equals 15. So my final solution is going to be y equals to -4 e to the 4t cosine of t plus 15 e to the 4t sine of t. Okay, so that was that one. Let's do example 5, the last one. Okay, example 5 says finding the solution of a non-constant coefficient second order differential equation. Okay, so this one is going to be kind of related to what we're going to do next of our next lesson. So we're going to find a solution of a non-constant coefficient. So yeah, this time we were used to having a constant coefficient. Now what happens if we have a non-constant second order differential equation? So for example, our problem is 2t squared y prime plus ty prime minus 3y equals 0. See, this 2t squared is no longer a constant. So what do? And we are given that y1t equals t to the -1 is a solution. So how do we do this problem? So step 1, since we know that y1, let's assume y. So step 1. Since we know y1, let's assume y2 is going to be v of t times y1 of t. Step 2, so y2 is going to be t to the -1 because y1 is t to the -1 times it by v. Okay, so this is going to be your f, and this is going to be your g. So my y2 prime is going to be, you apply the product rule, which is, this is your f, this is your g, so your product rule would be t to the -1 times v prime plus v negative t to the -2 equals t to the -1 v1 minus t to the -2 v. So my y2 double prime is going to be t to the -1 v double prime plus v prime of negative t to the -2 minus t to the -2 v prime plus v 2 t to the -3. So I get y2 double prime, which is 2 t to the -3v minus 2 t to the -2 v prime plus t to the -1 v double prime. Step 3, plug into differential equation. which is 2t squared. Wait, so what am I doing? Plugging into differential equation. So all I'm doing is replacing my v. So y2, I'm replacing my v with what I'm doing. I'm plugging it into my differential equation, so it's going to be 2t squared times. Oh, I'm plugging it right here. That's what I'm doing. So t to the -1 is 2t squared. That was given. And then all I'm doing is replacing my v prime with this. It's going to be 2t squared, 2t to the -3v minus 2t to the -2v prime plus t to the -1 v double prime plus t to the -1 v prime minus t to the -2 v minus 3 times t to the -1 v equals 0. And if you clean that up, you're going to get 2t v double prime minus 3v prime equals 0. So now our coefficient is constant, right? Oh wait, no, it's not. So we have to do some more substitution, right? This is not constant. We still got to do more substitution. So what we'll do is let w equals to v prime and w prime equals to v double prime. So that's going to be 2t double prime minus 3w equals to 0. Step 5, now solve the first order linear differential equation. Okay. So it's going to be okay. Now it is. So if you look here, this is now the constant is the coefficient is constant now. So now you can first. So now you can solve it. So it's going to be y prime minus 3 over 2t w equals 0. Now we can solve this. So what we have to do is to solve this first order linear differential equation is use the find your mu, which is e to the integral pt, which is, or pt is -3 over 2t of dt. And what is the integration of -3 over 2t? So this -3/2 is a constant. That is going to be -3/2 ln of absolute value t. Okay, so that is going to be, so your mu is going to be e to the -3/2 ln t. And then this is a constant, so it's going to be, this is a number in front of the ln t, so you put that in front. So the ln and e cancel, so you're just left with t equals -3/2. So that means our w is going to be ct raised to the 3/2. Okay, step 6, now convert back to V. And that V prime is equal to W. So V is going to be the integration of W dt, which is going to be 2/5 ct raised to the 5 halves plus k, or you could say t raised to the 5 halves. Step 7, so we know y subscript 2 is t to the negative 1/2 times t to the 5 halves, which equals your y2. So that means your t is going to be 3 halves. So my journal form is going to be y of t equals to c1 t to the negative 1 plus c2 t to the 3 halves. Okay, we'll do more of these problems in the next lesson. So I was just giving you like a brief introduction. What happens when your coefficient is no longer constant. Okay, we're gonna stop here.